All right, guys, we're going to take a look at questions 5 and 6, and then we're going to have you finish up the rest of these on your own. Okay, number 5 says the height in feet of an object dropped from the top of a building after t seconds is given by this function, h of t equals negative 16t squared plus 144. How many feet did the object fall between 1 and 2 seconds after it was dropped? Right? I'll call that part A. B, determine algebraically how many seconds it will take for the object to reach the ground. All right, this is what we're going to do. They're giving you the equation. Anytime they give you the equation, plug it in, graph it. All right, so here's our equation. Negative 16. Where there's a t or another variable, you're going to put an x in its place. So negative 16x squared plus 144. I'm going to go to the graph real quick so you can see what's going on. All right, again, time has to start at 0. So we don't look at anything before 0. So none of this is even relevant. We're going to start at 0. So honestly, you don't even have to look at the graph. You really could just look at the table. And we're going to always start at 0. All right? You're going to see the height is dropping until finally it hits 0. Think about what happens when it hits 0. This means that y represents the height. So when this is 0 for the y, that means it hit the ground. So a lot of these questions you could do by writing the table of values. Right? That's what I would do if I were you for every one of these. So I got 0, 144, 128, 280, and then at 3 it hits 0. I don't go any further because once I hit 0, it hit the ground. All right, so part A. How many feet did the object drop between 1 and 2 seconds? So at 1, it was 128 feet. At 2, it was 80 feet. So I'm going to simply do 128 minus 80. So 48 feet. That's how much it fell. B. Determine algebraically how many seconds it will take to reach the ground. Now, I really want you to get an answer for this. If you have trouble showing it algebraically, it's not the end of the world. You will get a point for getting the answers. So how many seconds will it take for the object to reach the ground? Well, at 0, it hit the ground. So how long did it take? 3 seconds. All right? I'll show you that quick, though, algebraically. So we have h of t. H stands for height, equals negative 16t squared plus 144. When it hits the ground, the height is 0. So I put 0 in for h. So this one is very similar to the one we just did on the front. I'm going to subtract 144 on both sides. You get negative 144 equals negative 16t squared. Divide by negative 16. You get 9 equals t to the second. You do the square root, and you get t equals 3, right? Which is what we got earlier. All right, last question, number 6. And then you guys are going to try these on your own. It says a toy rocket is launched from the ground straight up. The height of the rocket above the ground in feet is given by this function, h of t, height, based on time, equals negative 16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in a given context. Now again, I'd be plugging this equation in. So negative 16x to the second plus it's 64t, so plus 64x. You can look at the graph, but honestly, the graph doesn't matter. What we really want to look is the table of values. So again, we start at 0, we end at 0. We start at 0 for the x, and we end at 0 for the y. So we're going to go from 0 to 4. This basically tells us everything we need to know. Right, at 0, it's 0. At 1, it's 48. At 2, it's 64. At 3, it's 48. And then at 4, it's 0. And it says, determine the domain, the x values, right? So the domain is 0 to 4. They say explain your reasoning. Well, the rocket hits the ground in 4 seconds. And that's your explanation. Now, they could ask us other things like what's the maximum height? If you look at your calculator, the maximum height, it goes from 0 to 48 to 64, back to 48, back to 0. So if they ask what's the maximum height, 64 feet. If they asked how long does it take for the rocket to hit the ground, well, it hits the ground when the time's 0. That's 4 seconds. The only other question they really tend to ask is how long does it take for the rocket to achieve its maximum height? And that's when it hits 64 feet, 2 seconds. So a lot of this is interpreting the information you get off the table of values, right? Try these questions out, and I'll post solutions tomorrow. Thanks. Bye-bye.